Hello students. Now we will be discussing what is the gravitational field. Consider two objects A and B with masses ma and mb respectively and separated by a distance r. Okay, the gravitational force on the particle B due to the particle A is given by Newton's law of gravitation. We know Fb, force on B with respect to A, Fb is equal to minus GMAMB by R square RAB. Okay, it is a negative sign which shows that force is attractive, and RAB is a unit vector drawn from A towards B. Okay, now the ratio FB by MB is called the gravitational field due to MA. So the ratio of force divided by the mass, it is termed as gravitational field. This field is denoted by GA. Gravitational field is denoted by GA. This is the field due to A. Therefore, GA, the vector GA is equal to FB by MB. That is equal to, when we divide FB by MB, you get minus GMA by R square RAB. This is denoted as the gravitational field due to the mass MA. Okay. This idea can be generalized. If the gravitational field at a point in space is G, the gravitational force on mass m at that point is given by F is equal to the product of gravitational field G into the mass at that point. So mg. G is the gravitational field into m gives the gravitational force on the mass m at that point. Now the dimension of gravitational field is F by m, that is equal to acceleration. The acceleration of mass m by gravitational field G is given by F is equal to ma, that is equal to mg. Therefore, A is equal to G. Thus, the gravitational field at a point is numerically equal to the gravitational acceleration experienced by a body located there. Once again, thus the gravitational field at a point is numerically equal to the gravitational acceleration experienced by the body located there. Okay. For example, the gravitational field of the earth is G. Next is the electrostatic field. One of the salient features of the electrostatic force between two particles is that the force, like gravity, is an inverse square central force. It is very much similar to the gravitational force. It is similar to in the case that it is also an inverse square law, and it is also a central force. The force depends upon the fundamental property of the particle, which is called the electric charge. Okay, so you can find that it is also the fundamental property here is the electric charge Q, and it is an inverse square central force. Now there are two types of electric charges, which we term it as positive and negative, and experimentally like charges repel. Like charges, same type of charge. That means like charges repel and unlike charges attract each other. Now the electrostatic force FBA on the charge QB due to charge QA. It is FBA. It is the force on charge QB due to charge QA. It is given by FBA. The vector FBA is equal to a constant of proportionality K into QA into QB by R square, and with the the direction is in the unit vector VA. Unit vector RBA. K is called the constant of proportionality, and RBA is a unit vector that points from A to B. RBA points from A to B. Okay. Now the two type of charges are assigned the sign, algebraic signs of Q, either as positive or negative. Q is termed as two type of charges, positive or negative. If QA and QB If both are negative or both positive, you get the relation to be product of minus into minus as plus and plus into minus, plus into plus, that is also positive. The force is said to be repulsive. Okay. If both QA and QB are both negative or both positive, the force is repulsive. And if the charges have different signs, then FBA is attractive. If the charges are of different signs, the force is attractive. So, electrostatic force, unlike gravitational force, it can be either repulsive or attractive. That is the difference between these two types of forces. In SI unit, the unit of charge is given by the Coulomb, which is defined in terms of electric currents and magnetic force. And the term K, the constant of proportionality, K is equal to minus 10 raised to minus 7 C square. It is approximately 8.99 into 10 raised to 9 Newton meter square per Coulomb square. Or approximately it is 9 into 10 raised to 9. 9 into 10 raised to 9 Newton meter square per centimeter per Coulomb square. Here C is the speed of light. Okay, it is defined in terms of electric currents and magnetic forces in terms of C. Now here I have to define another physical quantity similar to gravitational field, which is the electric field. E is the electric field. It is to be defined as the electric force on a body divided by its charge. Electric field E is defined as the electric force on a body divided by its charge. Okay. The electric field at R due to a charge Q at the origin is E is equal to F by Q. And we know the equation for F. When we divide it by Q, you get the relation E is equal to K into Q by R square into the unit vector R, which shows the direction of electric field. This has the similar direction of electric force itself. So this is the definition of electric field.